I always know when I'm at PPMA show because I'm walking along one of the blue carpets here and I see an Omron pick and place machine. There's a wonderful piece of theatre and it makes me know that I've arrived at PPMA show every year. I'm here with Stuart from Omron, owner, I guess, of that. Maybe not the owner of that machine, but certainly responsible for its presence here at this year's show. And Stuart, you've got some more things to show us from Omron this year that are right behind us. But for anyone who maybe inside or outside the industry who isn't completely aware of what it is that Omron does, give us that 10-mile view.
So yeah, a huge number of control and automation products. So anything from photoelectric sensors and relays all the way up to big robotic systems. But what we have over here is some of our vision equipment, which is something that we've been doing for many, many years. And we've really been working to develop some new groundbreaking technologies for the food and FMCG industries.
Groundbreaking, and again, as you're walking through the hall, very eye-catching. So tell us what it is that we're looking at here then, Stuart.
So we actually have 4 demos here. So the first one we have is what we call a line scan camera. So traditionally we've looked at some of these labels that are going around, and we would look at actually looking at the label as a whole to try and find defects, whether that's little white specks on it or smudges or things like that. What we're actually doing now is looking at it through very thin lines, line by line. So what that does is it gives us much faster scanning time, enabling us to get through the labels much faster. And we get much higher resolution, so we can pick up much smaller defects.
And speed really is of the essence as we see this drum spin around with those labels on incredibly quickly, and we see the detection there taking place quickly. Do you put a number on this in terms of number of labels you can scan? I guess there's different ways in which you can configure that, but do you put a metric on that?
It depends on the complexity of the scan, but this one is running at about 100 scans a second, so it's running very quick.
Very quick is a good number for me. Speaking of very quick, we're seeing what look like some milk bottles, I guess, rolling around very quickly there, or similar sort of thing. What are we looking at from a technical point of view?
So from a technical point of view here, this is what we call our AI defect inspection system. So this is something that's really exciting and really fascinating. So what we're actually looking for is we're looking down through the bottle to the bottom, where we know that there may be some indentations, but we might not necessarily know what they're going to look like, and we might not necessarily know where they are. To complicate that a little bit more, we also know that there are indentations that should be there at the bottom of the bottle. So how do we differentiate from those, but also pick up those really minor defects? So by teaching this a number of really good examples, and then starting to build a machine learning algorithm to start to build that bigger picture, we can then start to pick up really minor defects. And we see this starting to be deployed in loads of different applications in quite a lot of different industries as well.
Yeah, exactly, the power of machine learning there. Just from a technical point of view, I guess what we're seeing there is we've got the camera unit with the lens on top, and we're seeing like a little flash there. Is that to enable nice clear vision inside the bottles?
Absolutely, 100%. Yeah, so it's quite funny because we take a look at this here and we see some white marks there and we think that's the defect, but actually that's just a reflection of the light. So that's actually really what we're looking for. So yeah, that's really just to make it as easy as possible to get a good read.
Spinning even faster than those bottles, I think, are these bottles here, and on the display up above. Wow, less defect on the bottom there. Is that perhaps we're looking at the label on top? Is that a good read?
We are looking at the label on top, but what we're actually looking for is an invisible barcode. So this is perhaps the most exciting demo that we have here this week, which is what we call our digital watermark demo. So we're looking for, at the top of this bottle, there will be a number of really small 2D codes that will contain a variety of different information about the ingredients that have made the product, the quality of the packaging, the materials used in the packaging, are they single-use plastics, etc. So you can't see that with the naked eye, but we can capture that with the camera. And we're starting to see this a lot more in the home and personal care sectors.
That's incredible. So these are 2D barcodes, like you say, but they aren't intended to be, I guess, visible. I mean, the great thing about barcodes, whether they're 1D or 2D, is that you know they're there, for instance. But these ones here, this is for internal control, internal quality control, and so on. And, well, I guess further down the line as well, places where you wouldn't necessarily want a consumer or a retailer to necessarily know that they're there, but you still got that traceability throughout the supply chain.
Absolutely, and it stops brand owners from having to put lots and lots of codes all over their packaging, therefore taking away the amount of space they've got for their own branding.
And again, just taking a look down here, the rate at which these codes are being read, by eye it looks pretty mind-boggling. Is there a number that you would attach to that?
This one's scanning at about 26, 27 milliseconds per scan, so we're doing it just under 40 bottles a second.
Got you. That's what we're seeing up there. Fantastic. And finally, I guess, what are we looking at? I'm seeing some code here. I'm seeing some if then and if else if statements on there. But what is this doing in particular?
So what we have here is this is aimed at some more preventative maintenance and making sure that machines are running as much as possible. So what we often find when we're talking to customers is, my machine stopped, but I don't really know why it stopped. Something's clearly happened somewhere, but I can't see what it is. So what we will do is we will take a recording of the footage in the lead up to that stoppage. And what we can see here is if we look at the yellow data trace, we can see exactly when the speed has dropped to 0, and we can see exactly why it's happened on the video.
Because we've got some operator intervention there by the looks of it.
Absolutely right. But that could be anything from, there's been a jam in the packing materials, there's been some external interference from the environment, loads of different reasons, but it enables us to get to the bottom of what that reason is much more quickly.
I find it very exciting that we're starting to see AI in its various guises, machine learning here in particular, be applied really finally in this industry. I know that it's difficult just to jump on whatever the latest bandwagon is and start applying that, particularly when we're looking at machinery in this sector. But I really do get the feel, particularly with vision systems, that we're starting to see beneficial, valuable application of these technologies, not in trials and demos and so on, but finally we're starting to see that in the mainstream. Is that how you would see the market as well at the moment?
Very much so. The use cases for this technology, that we're uncovering new ones all the time, so it's a super exciting place to be.
Brilliant. And speaking of super exciting places to be, how's PPMA Show 2024 been?
Fantastic, as always. Yeah, great show. We always get a lot out of it. We get some really interesting conversations. We get some of the applications that we're good at, but we also get some weird and wacky stuff to keep us interested as well.
Brilliant. Well, I've really enjoyed this weird and wacky stuff here. It's not weird and wacky at all, but it's been really, really interesting. Stuart, thank you so much for chatting us through this. Look forward to seeing you again and what weird and wacky stuff you brought for 2025. But for now, thanks a lot.
Fantastic. Thank you.
Cheers.